Mercury is 4,879 kilometers in diameter, has an average temperature of about 430 degrees Celsius, and common elements include iron, nickel, and silicon. These elements are common because Mercury is close to the sun, and when the solar system was forming, hydrogen was sucked away from them by the sun, leaving these easy-to-condense elements.
A stellar nursery is a molecular cloud which contains the material for potential elements. This cloud is densely packed with hydrogen atoms, including diatomic hydrogen.
Venus is 12,104 kilometers in diameter. Its average temperature is about 470 degrees Celsius, and common elements include sulfur, carbon, oxygen, nitrogen, iron, and nickel, along with silicon. These elements are common for the same reason they are common on Mercury.
A protostar looks like a main sequence star, but it is not yet hot enough for a core to fuse. At this stage, the star is still mostly hydrogen.
Earth is 12,750 kilometers in diameter, has an average temperature of about 21 degrees Celsius, and common elements include iron, cobalt, nickel, silicon, and carbon. These elements are common for the same reasons they are common on Venus and Mercury.
A main sequence star is so dense that fusion will occur. The hydrogen atoms will become helium atoms in their cores. From here, two things can happen. It could either become a red giant or a supergiant. Red giants are even larger than main sequence stars, so dense that most of the hydrogen has become helium.
Mars has a diameter of 6,800 kilometers, has an average temperature of negative 55 degrees Celsius, and common elements include iron, nickel, sulfur, magnesium, aluminum, calcium, and potassium. These elements are common on Mars for the same reason they are common on Mercury, Venus, and Earth.
Then planetary nebulae form. When the star sheds its outer shell, the elements carbon, nitrogen, oxygen, and neon occur.
Jupiter has a diameter of 139,882 kilometers, has an average temperature of negative 143 degrees Celsius, and common elements include hydrogen and helium. These elements are common in Jupiter because Jupiter is a fair distance from the sun. When a rocky core formed, it was able to accumulate a large cloud of gas around it, forming a gas giant.
In white dwarfs, there is no more nuclear fusion. The majority of white dwarf material is carbon and oxygen.
Uranus has a diameter of 50,724 kilometers. Its temperature is about negative 224 degrees Celsius on average. Common elements include iron, nickel, and silicon. This is because Uranus is an ice giant. It is far enough from the sun that when it was forming, it didn't have enough hydrogen and helium to gather around to become a gas giant, but had enough material around it and was cold enough for chemicals like methane and ammonia to crystallize into kind of a snow.
Finally, the star becomes a black dwarf, which emits no light. There are known black dwarfs in the universe.
Saturn is 116,464 kilometers in diameter. Its average temperature is negative 178 degrees Celsius. Common elements include hydrogen, helium, oxygen, nitrogen, and common compounds include ammonia, methane, and water. It is large for the same reasons that planets like Jupiter.
A supergiant is so hot and dense that oxygen, neon, and beryllium are already occurring. This will continue until iron is created, then the star will explode, causing a supernova. Within the supernova, gold, silver, and lead occur. From here, two other things can happen. The supernova could collapse into a neutron star, also comprised of gold, silver, and lead. Or it could become an internal implosion, or rather, a black hole, in which carbon, nitrogen, oxygen exist, as well as the molecules water, carbon monoxide, and hydrogen cyanide.